Welcome again to today's class. In today's video, we want to discuss another important experiment in physics. That is experiment on upthrust in a liquid. In this case, we want to discuss water as a liquid, so to speak. Now, it has the objective to determine the upthrust of a liquid, that is water. Apparatus, you see vernier caliper, a 250 ml beaker, weighing balance, metal blocks of different weights, thread, and what? Water. Look at the diagram. This is just beaker. This is talking about 2 ml what? Beaker. Okay? Then this is water at 150 ml, and this is 250 ml beaker. Okay? Let's see the procedure, so to speak. You are provided with an empty 250 ml beaker. Determine the internal diameter of the beaker. Look at the diameter. This is the circular part of the word beaker. So the diameter means like this. You have to get this distance. Okay? You have to get this distance. That is the diameter. Okay? They say determine the internal diameter of the beaker with the aid of the vernier caliper. So you have to mount the vernier caliper like this to get the word diameter, or you fix it inside such that it will get the word diameter. Just package it well. Then weigh the 250 ml empty beaker and record its mass as MO. Wow. So when you take your weighing balance, get the weight of the 250 ml beaker. As I check my own, I got 100.7 grams. So you check your own weight and see what it will give you. Actually, this should be taken as the mass. I got the mass. To get the weight, you divide it by 1000, then multiply it by 9.8. That will be the weight. This is just the mass you get with chemical balance or beam balance, etc. So when you get the mass in gram, divided by 1000, then it will go in kilogram, then multiply by 9.8, it will be in what? A note. That is the weight. Okay. Pour some water into the beaker to the point of depth HO of 150 ml. Wow. So the distance from here to here is HO. So as I pour the water now, they said weigh the beaker with the water content and record its total mass as M1. Now, because we want to perform this experiment without touching apparatus, as you have known the mass of the beaker, the implication is that mass of the beaker and water, mass of beaker and what? Water will be equals to, since the water is 150 ml, there are some conversions you need to note. One is that 1 ml is equal to 1 cm cube. 1 ml is equal to 1 cm cube, and is equal to 1 gram. Is equal to 1 gram. And so we are getting it this way because we said that density is equal to mass over volume, and mass is equal to density times volume. Density of water is 1, volume is 150. So 1 times 150. That means this 150 ml is equivalent to 150 gram of water. From density times volume equals to mass, and density of water is 1 gram per cm cube. So you multiply, it will be giving you 150 gram. So you call it 150 gram. That is it. You say that this 150 gram plus this will now be giving you 250.7 what? Gram. That is the mass of the beaker and water, and that 150 ml of water. Okay, weigh the beaker with the water content and record its total mass as M1. So we call it M1. Gently immerse completely the metal block mass X 20 gram into the water with the aid of a thread. Find the depth of the water, that is the height. So you measure the height of this water, the height of it, use your ruler to measure it. So as I measure it, I was getting 5.4 cm. The height of the 150 ml of water was giving me 5.4 cm. So that means two things are what you have to do. Weigh the what beaker to note the value, then get the height of the water to note the value, then you can go direct and do your manipulation without wasting your time anymore. Then they say find the depth of the water height h and find the change in depth of water h minus ho using a equals to pi d square over 4, where a is the cross sectional area in cm squared. Determine a and ah, where h is the depth of water in the what beaker. Repeat the procedure with x equals to 30, 40, 50 something gram respectively, and determine accurately the corresponding depth h of the water and ah. Tabulate your readings. This is just trying to tell you that as you are seeing this like this, as you are seeing this water here, when you immerse 20 gram, it will displace its own weight inside this water, and as it's displacing its own weight inside this water, the volume of water will increase. That is just point number one. Then when you also do the one of 30, 40, 50, the height will be increasing, and that is the concept of this what experiment. Okay, we have succeeded to get the mass of the empty beaker to be 100.7 gram. So two things are what you just need: the mass of empty beaker and the height of the what 150 ml water given to you. Are you getting it? And so next they say we should get the mass of the empty beaker with water, and we say it's 250.7 gram. As far as we have gotten the empty beaker, we will tell them that since we are talking about water, density of water is 1 gram per cm cube. We now tell them that density times volume is equal to mass. So 1 gram per cm cube times 150 cm cube, which is equivalent to 150 ml, that will be giving you 150 gram. So 150 gram plus this will be giving you 250.7 gram. So you achieve that. The height is 5.4 cm. That is the height. Now, what we need to do again is, you recall from mensuration of solid shapes that when you have a cylinder, volume of a cylinder is equal to base area of that cylinder times height. So we tell them that this water we talk about, they have given us the volume of water to be 150 ml, and we have gotten the height of that water. And this water takes the same base with the base of the cylinder. They take the same base. And so what we say is, we say volume is equal to pi d square over 4 times height. This is because volume of any solid shape is equal to base area times height. You know that how we got this formula is that this is in a circle. The base of that beaker is in circular form, and every circle has area to be pi r squared. That is area of a what? A circle. But because they expect us to get the diameter, we remember that r is equal to d over 2, and putting it here, it will now be pi d square over 4. That is how we got this area. So base area times height is equivalent to volume. So once we have gotten the height of that volume, we can get the area. We now tell them that 150 is equal to the area times what? 5.4 cm we got. Therefore, the area of this what? Base will be equal to 150 over 5.4. We say 150 ml is equal to 150 cm cube. because 1 mil is 1 cm cube. So when you compute this with your calculator, we have 150 divided by 5.4. That will be giving you 27.8 cm cube. That is the area. Yes, that means we have gotten the area of the what? Of the what? The base, which we said the base of the water is the same thing with the base of the container, because water takes the volume of the what? I mean, it takes the shape of the what container is inside. Now we have gotten our area to be this. Now they say we should get our d. We tell them that pi d square all over 4 is equal to 27.8 cm cube. Making d square subject of formula. Therefore, we say that d will be equal to, as you are seeing it here, we say that pi d square is equal to 27.8 times 4. D square is equal to 27.8 times 4 all over pi. Right? Yes. And so we also say that d will be equal to square root of 27.8 times 4 all over what? Pi. Okay. So that means what we'll be writing there is square root bracket 27.8 times 4 divided by bracket what? Pi. That will be giving you approximately what? 6 cm. So that means the diameter of the what? Of the beaker is 6 cm. So we also note it. We say the diameter is 6 cm. Our MO is equal to 100.7 gram. Our MO1 is equal to 250.7 gram. Our area is equal to 27.8 cm squared. Area is in squared, please. Yes, we have gotten the parameter. The volume is constant. Okay, the HO is equal to 5.4 cm. Wow, we have written down all those parameters. So the area is constant. We'll write it here. 27.80, 27.80, 27.80, 27.80, 27.80. Okay? Then the height, this is H. We have to look for it. Then our HO is 5.4. We have to have it in our mind. Your temple is the body of Christ. Now, we noted that density of any substance is equal to mass of that substance all over the volume of it. The volume of that substance is equal to mass over density. Now, what substance are we talking about? In this video, we are talking about steel. In most labs, steel is what we use as our mass. The mass comes in terms of steel. And so the density of steel is between 7.775 to what? 8.05 gram per cm cube. That is density of steel. And so we just take, let's say we just take 8.05 as our density. We now say that This volume is equal to mass over density. Now, when you are talking about steel and you are not able to get the volume of that steel, what it simply means is that put that steel inside water. When you put it inside water, take note of the increase in height. Look at the initial height. So this one is the height you will get when you put it inside water. Now, that means the steel displaces its own weight in that water by increasing the volume of that water. And so to get the weight or the mass of the water it displaced, we will say this height minus this HO. We will get the height it displaced, height of the water is displaced. The height of the water is displaced times the volume of that what beaker or the volume of the water will be giving you the volume of that what of that steel, so to speak. And so we say volume of that steel will be equals to the height, the final height it will get when you put the steel inside and it displaces its own weight, minus the original height of that water before you put the steel inside, times the area of the what of the base, which is same with area of the water or area of the beaker, of the base of the beaker. And so bringing this down, we'll be having that mass over density, mass over density times what? Area, plus this go this side, HO is equals to H. So we say that HO plus mass bracket area times density is equal to that height. That means if I say 5.4 plus 20 all over 27.8 times density 8.05. Once I compute this, it will give me the height we will get when you put 20 cm of that, when you put 20 gram of that mass, when you put 20 gram of that steel inside this water, it will give you the increase in height. I mean this final height. It will displace its own weight and increase the volume of water to that height. That height it will get is what we get from this. So we now tell them that therefore height is equal to this. So we press it in our calculator. We say 20 divided by bracket 27.8 times 8.05 plus 5.4. That will be giving you 5.48936 continue. And that is in centimeter. Now, because you can't get this with your what? Meter rule. Reading accuracy of meter rule is 0.1 cm or 0.0 like 0.1 cm or 0.1 cm. That means what you can get is 0.1 cm. That is reading accuracy of the meter rule. Now that means what you have here, you have to be approximated to one decimal place. That will be giving you 5.5 approximately. You write it here, 5.50. Then you do same by putting 30 here. You put 30. You say 30 divided by bracket 27.8 times 8.05. That will be giving you then plus 5.4. You will be getting 5.534. 5.5340 continue. Now, because we cannot get this with our meter rule, centimeter rule, we can say let us approximate it to 5.55. We have here 5.55. Because we can get 5.5, 5.6, and in between 5.5 and 5.6, that is 5.55. Okay, we change here to 40. 40 divided by bracket 27.8 times 8.05 plus 5.4, 5.578. This will give you 5.5787. Wow, we approximate it to 5.6. Then we go again. We change it to what? 50. We say 50 divided by bracket 27.8 times 8.05. We have then we 50 divided by bracket 27.8 times 8.05. We'll be having, okay, plus 5.4. We'll be having 5.623 for continue. So we can't get 5.6234. So we approximate it to what? 5.65. Just round it up to what you can get. Then you get the one of 70. Change here to 70. 70 divided by bracket 27.8 times 8.05 plus 5.4, 5.71. We approximate it to 5.70. We have gotten our height. Now we have gotten this and we have gotten this. We subtract this minus this will be giving me 0.10. This minus this 0.15. This minus this 0.20, 0.25, 0.30. Stay in cm. AH means multiply A with H. We have 27.8 times 5.5. That will be giving you 152.90. We now also say times 5. That will be giving you 154.29. Then multiplying again by what? By C0, it will give you 155.68. Multiply this with this 65. 157.07. Then 70. Multiplying 5.70, we'll be having 158.46. And so with this approach, you have gotten your table for this experiment. Just note the mass of the empty beaker, that is 1, and note the height of the water, that is 2. You are good to go to do your manipulation. We have gotten our table of value. The unit of AH is cm cube. cm cube, area times height, cm cube. Okay, so next is for us to plot the graphs and answer questions that will follow it up. Okay, so don't forget that as every experiment you have to write the precautions that follow it, and one of it is for this one, error due to parallels. You have to be very careful with that because you are trying to measure out the distance from here to here, so error can occur due to parallels. Parallels error can come up here. Are you getting it? Then as you are measuring this height of water displaced, error can also come in there. So error due to parallels is avoided or is taken care of by taking my reading vertically downwards on the meter rule. You say the error you try to what? Avoid, and how you avoided it by taking my reading vertically downwards on the meter rule. Another error you should take note of, another precaution you should take note of is while trying to immerse that mass inside the water, ensure care was taken while immersing the mass inside the water by ensuring that it did not touch, or it doesn't touch the side of the beaker, and also that it does not splash water out, so as to what enhance accuracy. Okay, so try to include your precautions while you are done with every experiment, whether they ask you to do so or whether they didn't ask you to do so. Don't forget that. Thank you for watching this part. Let's go into graph plotting.